Alright guys, so today we'll be talking about Docker, and I'm going to try to explain this right from the perspective of the developer. So let's start. So this is you, yeah, that's you, a good looking software developer. Most likely what your day-to-day job would entail is that you write code on your machine. But if all goes well, this code will not just live on your machine. You're going to push it somewhere to like a server, right? This server is just like a special machine, maybe somewhere in the cloud, right? And users can make requests to this server. Let's call these guys users. They can make requests to this server, and in return, they get access to your application, right? Your application is served to them. So this is what your day-to-day, this is what like your general or the most common workflow for developers would be, right? Now that is just one way. Another way to look at it is that this would not just be pushed directly to server. So another thing that could usually happen is that you write this code and you push it to something called a repository, right? Repository, right? And in this repository, this could be something like GitHub. This could be something like GitLab. You understand? And the rest, Bitbucket and the rest, right? So you put this code to like a repository, and other developers can pull your code, other members of your team, right? Let's say devs plus maybe QA, whoever, or DevOps personnel can pull this code down into their own devs can put this down into their own machine, right? And they need to like do stuff with the code, maybe contribute to the code base or stuff like that, right? Yeah, so this is a workflow that as a developer, most of us are familiar with. Now, but one thing you will notice with this is that there are some things to take into consideration, right? Let's go back here to where you started writing your code. Now, for your code to work well, right, it would need to have certain dependencies, right? So let's come here, let us say dependencies, right? So let's assume you're building a backend server with JavaScript, for example. So you need some sort of library that could help you with the server. Let's say command one would be Express, right? Some people could use maybe Fastify or whatever. You could have like some sort of other packages that helps you connect to like a database, let's say maybe Mongoose, right? You understand? So these are like libraries installed for your backend server, right? Now, obviously, to use all these libraries we just spoke about, you need something called like the Node.js runtime, right? So for you to have that, you need like Node.js, right? You understand? So libraries, and these libraries like require Node.js, right? So these are like, this is what the full length of your dependencies would be like, right? Now, but it's not just that you need a Node.js, right? Let's say if on your machine here, you had, let's say you had Node, let's just say Node 18 installed, right? And if one of these persons, or maybe the DevOps administrator or any of these guys had like an older version of Nodes, let's say for whatever reason they had like maybe Node 13 or 14, right? Now, this, as simple as this already causes like an issue, right? Because if something is on like a newer version, and these guys don't have like a Node version that's compatible, that already causes an issue. Now, of course, not just that they have to have like the exact version of Node, they have to even have Node.js installed, right? Now, this brings up the problem, right? So you have to, now, one thing you could do is to always go around and say, oh, on this server, let's ensure we have Node 18. On your machines, please install Node 18, maybe use like an npm file, right? You understand? But that causes a hassle. So what happens when you don't have Node installed? And mind you, I'm just using Node as an example, right? This could be, Python, right? It could be PHP or whatever, right? It could be something else. It could be a different language entirely, right? So you need something that can like take that and compile it and stuff. So what do you want to do? Do you want to go around and start saying, "Hey, man, have this runtime install, have this runtime install"? What if we could take our code, right? So you take your code plus dependencies, everything your code needs to run, right? And you put them into a box, and this box becomes what you ship out to, um, you ship this box to like, some sort of, let's say, hub, right? Or registry. You understand? And what happens is that developers can pull that version of that stuff and they run it on their machine, right? So everything you need, they pull your code, and they don't just pull your code, they pull everything that your code needs exactly to function well, right? And they run it on their machine, right? This box, we call this box, and there's something like this, we call this box a container, right? So this is the concept of this idea of putting your code and dependency into your stuff. This is what this is. This has to do with the concept known as containerization, right? So I'll write that out correctly. So this is called containerization, right? And the most common technology used for doing that today is called Docker, right? So this is just that. So basically the idea is, once again, get your code, dependencies, put them into like something called like, package them together, and that becomes what you ship, right? So across different places. So whether you're running it on the server here or you're running it on different machines that you don't know about, you can provide a consistent environment for your application to run, right? So that becomes the concept. Now the question becomes, how do we how do we like how do we go about like building containers and stuff like that? Cool. Now there's also a simple step to that. So you have something called a container, which, like I said, is your code plus dependencies, right? Now, but for you to build this container every time consistently, you need some sort of blueprint, right? This blueprint, we call it an image, right? So this is called like a Docker image. So this is what you actually build, right? So you prepare this blueprint, you understand, and every time you send this blueprint out, people can, based on that blueprint, they can spin up like a running version of this stuff. They can spin up a running environment, and that this environment is like a container, right? So how do we know what should be inside the container? We need a blueprint. This blueprint, we call this blueprint Docker image. So we move from image to container. Now, to get this image, you understand, you have like something called a Docker file, right? A Docker file is just like a set of specifications and instructions. You understand, like, okay, what what should be here, what steps should follow, right? So okay, step one, uses runtime, right? So we call that a base image, right? The next step would be to copy certain files, install these set packages and stuff like that, right? So that's what a Docker file. Think of a Docker file like a set of like a script, a set of instructions that should run, and based on that, based on those set of specifications, you can build your image, and your image is what you ship out to like the hub, and people can pull that and they run a container. By the time they run a container, they have your code and everything it needs to run together along with it. Cool. All right, guys. So this is just like an introduction to the concept of containers and what Docker would do, right? So I hope this gives us like an insight and a clear picture. In the next section, what we're going to do is that we are going to like take this and put this into practice. We're going to see how this works. We're going to Dockerize a full stack application. We're going to have like a client. We're going to have like some sort of backend. And we'll put this in Docker first, and then we'll put this next, and we would show how like they can communicate with each other. All right, thanks for watching. See you guys in the next video.